Madeline for Algebra 2. In this video, I'm going to go over some of the problems from the Unit 3 review sheet. We're specifically going to start with example number 2. So we have a radical equation, and the first step is to make sure that your radical is isolated, and it is in this example. The next thing is you square both sides of the equation. The square of a square root is just what appears under the radical, the radicand. So we'll rewrite that. And x minus 7 squared, you're going to have to expand out. We're going to double distribute the right-hand side of the equation. To get x squared minus 7x plus 49. We combine like terms on both sides of the equation, and we get x squared, negative 7x is negative 14x plus 49. We now need to place the equation into standard form since it's a quadratic equation. I know it's quadratic because I have an x squared term on the right-hand side. So I'm going to subtract 25 and add 3x to both sides of the equation. When I do that, the left-hand side becomes 0 and the right-hand side becomes x squared minus 11x plus 24. We now have a quadratic equation in standard form, and so the next thing that we have to do is factor. So notice that we have a trinomial with a leading coefficient as 1, so I can use the regular sum product method, the x game. So we're looking for two factors that multiply out to positive 24 and add to negative 11x. So because you're multiplying to a positive number, both sides have to be the same, and in this case, both sides are negative because it has to add to a negative number. Those factors, you would list them out. You have 1 and 24, 2 and 12, 3 and 8, 4 and 6, and that's all the factors. Again, they both have to be negative since it has to multiply out to a positive number. And the factors turn out to be negative 3 and negative 8. So we factor that, and now we solve. So we set each factor equal to 0, and we get one root is 8 and one root is 3. You now have to check. So when you check, you check in the original equation, not the squared one, but the original. And we get, let's first check 8. So 25 minus 3 times 8. Is it equal to 8 minus 7? So that's 25 minus 24, which is square root of 1, which is just 1. And the right-hand side is 1. So we know that 8 checks. So now we have to do the same thing for 3. So 25 minus 3 times 3, is it equal to 3 minus 7? That's 25 minus 9, which is 16. Is it equal to negative 4? 4 does not equal to negative 4. So we are going to reject this root because it is extraneous. So the only solution in this case is 8, which we put in braces. Problem number 3. So we're asked to find all real solutions of f of x equals 0. So in other words, they want to find the values of x that make the equation equal 0. They're looking for the x-intercepts, also known as the roots, also known as the zeros, or just the solutions to x. So those are all different ways we ask the same questions. So we look at each of the roots, and we have one root as -3, one root as -4, and one root as -2. There actually is a repeated root at -4. I can tell because of the bounce. But in this case, when they're asking for these questions, they only want the unique roots. And so these are the unique roots. Problem number 4. This is a table, and in this table, they're asking you to identify the degree, the leading coefficient, the end behavior, and the y-intercept of these two problems. So let's start off with part B because it's a little easier. And so notice how the function, even though it's not in standard form, is not in factored form. In other words, the highest degree is not shown first. So when you're determining the degree, you really only need the term containing the highest exponent, which in this case is -6x cubed. So the degree of the function is simply 3, which is an odd value. The leading coefficient is what's attached to the x cubed term, which is -6. And even though -6 is an even number, for the purposes of the leading coefficient, we just need to know whether it's positive or negative. So because it's positive, I know that the ends are going in opposite directions. So ends of the polynomial are going in opposite direction. Because a is a negative value, we know that the right side is going to point to the negative direction. So the function is going to look something like this. It's going to rise to the right and rise to the left and fall to the right. Remember, opposite directions, but because the leading coefficient is negative, the right side is going to point towards the negative direction. So in function notation, as x, let me do that in blue, as x approaches -infinity, your y values, your f of x, is going to point upwards, up to infinity. As your right side is going, as x goes towards the right, x is greater than infinity, your right side is going to point down to -infinity. Okay? Okay, so that's the end behavior. And finally, to get the y-intercept, you're going to substitute 0 in for x. And so, therefore, the only value is 10. So the y-intercept is, or the y-coordinate of the y-intercept is 10. Okay, now let's go to the opposite side. Let me choose, let's see if I can choose a different color for this. I'll do purple. Okay, so now what's different about A is that it's not expanded out, it's in factor terms. So you need to get that first term. You could expand the whole thing out, but that's taking extra time. That's not really necessary. So what's the trick of doing this? What you're going to do is take the first term of each component. So that first term, it's not really a term, but that first factor is not a binomial, and so you take the whole thing, that negative 3x. And then the first term in that second factor, which is 2x, and then the next, you could expand it out as x plus 4 and x plus 4 and just take x and x, but the easier way is just to say x squared. That will give you the same answer. Now you multiply it out. Negative 3 times 2 is negative 6. X times x squared is x to the 4th. Okay, so now what? So now I know that my leading coefficient, my degree is going to be 4. And it tells me also that my leading coefficient, that's what's attached to the x to the 4th, is negative 6. Well, 4 is an even number, so this function has an even degree, and the leading coefficient is negative, and that tells me that, what does that tell me? If the function has an even degree, the ends go in the same direction. And because the leading coefficient is negative, that means the right side points down or points to the negative direction. So what is the end behavior? The picture is going to look like this. They're both going to point down, okay? And so we would write it as x goes to the left. Your function is pointing down to negative infinity. And as x goes to the right, your function is going to also point down to negative infinity. The y-intercept, you're going to substitute 0 in. And you're going to see that that just multiplies out to zero, right? Because once we have that first term of 0, the whole thing is going to become 0. And that's just the y-coordinate of that function. We'll just go through the rest of the end behavior problems, and then I'll make another video for the other problems. Okay, so we just reviewed a little bit about the end behavior. So let's look at multiple choice questions on this topic. So the very first thing is this function is in standard form on number 5. The term containing the highest degree is negative x to the 5th, so n is 5, which is an odd number. That means that the ends are going to go in the opposite directions. A is negative. It's negative 1, so it's negative. So again, that tells me that the right side is going to point down, and since again they're going in opposite directions, the left side is going to go up. So let's go through the choices. And what I normally do is I make these little notations above so I don't, otherwise I can accidentally choose the wrong problem. So this is going, as you go to the left, you're going down, and as you go to the right, you're going up. Well, that's not what our picture shows. Number B, as you go to the left, you're going up. As you're going to the right, you're going down. And that's what our picture is showing, left up, right down. And so the choice is B. Let me take a highlighter. You really should go through the other choices just to make sure you don't accidentally pick the wrong one, but I want to try to keep the video a little shorter. Okay, number 6, that's the type where it's in not in expanded form, in factored form. So we have to find that first term first. So again, here's that coefficient, that's really -1. Then you're taking x cubed, the first term in that parentheses cubed, and now the second term in the parentheses to the 5th. And so that becomes -x, keep the base and add the exponents, -x to the 8th. That tells me that my degree is 8, which is an even number. That means the ends are either going to go up, up, or down, down. And a is -1, that's negative. And so that tells me that both ends are going to go down. So left down, right down. So let's go through the choices again. That's left down, right up. So that doesn't work. B, left up, right down. Well, that doesn't work. Left up, right up. That doesn't work. And you just want to double check. Left down, right down. That's our answer, and I just confirmed it. Number 7. Our function is not in standard form. You look for the degree containing the highest term, which is x to the 6th. So that means the degree is even. The ends are going in the same direction. And my leading coefficient is 1, which is a positive value. That tells me that my left side is going up and the right side is going up. Again, when you have an even exponent, the ends go in the same direction. They're either up, up, or down, down. And in this case, because I have a positive value, the right side has to go up. That means the left side has to go up. So let's go through the choices. Left down, right up. That doesn't work. Left up, right down. That doesn't work. Left up, right up. That's the answer. And I will make a video for the next series of problems.